June 6th, 1944. 6:32 hours. Over the Normandy coast. Low clouds hang over the water. The air smells of fuel and salt. A German fighter pilot grips his control stick. His engine roars, steady and sharp. Ahead, dark shapes fill the sky. American aircraft, hundreds of them. Machine guns flash. Tracers cut white lines through gray air. The German pilot dives. He expects panic, expects engines to cough or stall. They do not. American bombers keep formation. Fighters peel off with smooth turns. One Mustang climbs hard, straight into flak, engine screaming but never breaking. The German pilot frowns. He has seen rush machines before, poorly built ones. This feels different. Flak bursts rock the sky, metal tears, parachutes bloom. Still the American engines keep running. No smoke, no sputter, no fear in their movement. The German pilot pulls away, heart racing. Later on the ground, he will talk with other pilots. They'll ask the same question. How do they build so many engines? And why do they never seem to fail? The answer lies far from this sky. It lies in factories, in hands that smell of oil, not gunpowder, and in a decision that reshaped the war far beyond this moment. If you want more stories like this, make sure to subscribe, like, and share. In 1941, the United States faced a problem of scale. The country was not yet fully at war, but it was preparing. Modern air war demanded engines. Thousands of them. Engines that could run for hours at high power. Engines that could survive cold, heat, flak damage, and abuse. America did not have enough trained industrial workers. Millions of men were already in uniform or about to be. Factories stood silent or underused. The solution came from necessity, not ideology. Women entered heavy industry in numbers never seen before. They were trained to read blueprints. They learned torque limits, tolerances, and safety checks. Aircraft engines were complex machines. A typical American fighter engine produced more than 1,000 horsepower. It had hundreds of moving parts. Cylinders had to be aligned within tiny margins. Single mistake could seize an engine at altitude. Women built them anyway. Factories expanded fast. Assembly lines ran day and night. Training programs lasted weeks, not years. Quality control was strict. Engines were tested at full power before shipment. If one failed, the line stopped. This was not charity work. It was survival. By 1943, American factories produced engines by the tens of thousands. They powered fighters, bombers, transports, and trainers. They crossed oceans in crates. They arrived ready to fly. The enemy would soon notice the result in the sky. At first, the system struggled. Many supervisors doubted the workers. Some reports warned of high error rates. Early production runs had problems. Loose fittings, oil leaks, proper wiring. Training accidents happened. Engines failed on test stands. One report noted that nearly 1 in 10 early units needed rework. Pilots complained about rough idle and vibration at climb power. Mechanics grumbled that the assembly line was too fast. Enemy intelligence dismissed the effort. German analysts believed the output would be low quality. They expected breakdowns under combat stress. Some pilots joked that American planes were held together by luck. The jokes did not last. Factories adjusted, training hours increased, checklists became longer and clearer. Every worker specialized in a narrow task. Torque wrenches replaced hand tightening. Inspection teams doubled. Failure rates dropped fast. Within a year, rework rates fell below 3%. Engines passed endurance runs of 6 to 8 hours. They ran at high power without overheating. Misconceptions faded on the factory floor. They lingered in enemy briefings. That gap would soon prove costly. The real change came when crews learned how to use the engines fully. American pilots trusted them. They pushed power settings longer. They climbed harder, stayed in the fight when others disengaged. Engines could hold high revolutions without losing oil pressure. Cooling systems worked at altitude. Fuel injection reduced cutouts during negative maneuvers. Fighter could dive steeply, pull out hard, and climb again. Bombers held formation with fewer aborts. Mission completion rates rose, range increased. Escort fighters stayed with bombers deeper into enemy airspace. Maintenance crews reported fewer forced landings. One mechanic wrote that these engines forgave mistakes. The strength was not magic, it was consistency. Every engine matched the next. Parts were interchangeable. Field repairs were simple. Pilots learned exact limits and trusted them.
The sky became a testing ground.
The engines passed. In August 1943, over southern Germany, a bomber stream moved east. Nearly 300 heavy bombers flew at altitude. Escort fighters weaved above and around them. German interceptors rose in waves. One pilot attacked head-on. He fired, then broke away. Expected the bomber to fall back. It did not. All 4 engines held power. The bomber stayed in formation. The pilot attacked again. The engines still ran. Flak burst around them, shrapnel cut metal. One engine lost a cylinder, kept running. The bomber dropped its load and turned for home. Months later, over France, a lone American fighter chased a German aircraft at low altitude. The chase lasted minutes. The German pilot tried to force an engine failure. He flew through rough air and pulled hard turns. The American stayed with him. No smoke, no hesitation. At last, the German pilot disengaged. He landed with fuel, fumes, and anger. In June 1944, the skies over Normandy filled with aircraft. Transport planes, fighters, bombers. Engines ran from dawn to dusk. Some flew multiple sorties a day. A German flak officer wrote that American planes seemed endless and returned even when hit. In one case, a transport took damage over the drop zone. Oil sprayed across the cowling. The pilot reduced power. The engine held. He crossed the channel and landed safely. In another case, a fighter escort lost coolant. The pilot expected seizure. He stayed in the fight for 10 more minutes. The engine did not quit until after landing. German pilots noticed patterns. American planes stayed aggressive. They did not nurse engines. They did not break off early. One German ace said they trusted their machines more than he trusted his own. By late 1944, the imbalance was clear. American aircraft losses from engine failure dropped. German losses from mechanical issues rose. Fuel shortages made testing harder. Factories faced bombing, which the contrast sharpened with every month. Behind the front, production never stopped. By 1944, American factories produced over 90,000 aircraft engines in a single year. Training pipelines expanded. Replacement engines reached units within days. Maintenance manuals were standardized. Fuel quality stayed consistent. Enemy production struggled. Factories dispersed. Quality fell. Pilots received engines with limited test hours. Some failed within the first mission. American air power grew heavier. Sorties increased. Escort coverage extended. Bombing accuracy improved. The engine was the quiet backbone. Without it, numbers meant nothing. The pressure never eased. The psychological effect spread fast. German pilots spoke of American engines with unease. They called the fighters stubborn. They joked less. A diary entry noted that they did not fall away when damaged. Morale shifted. Pilots hesitated to engage long chases. They broke off earlier. Confidence eroded. American pilots felt the opposite. They pushed limits. They believed in their machines. One wrote home that she brought him back every time. The engine became a partner. Not perfect, but reliable. Fear did not vanish. It shrank. Late in the war, engines improved again. Power output increased. Materials improved. Cooling systems refined. Engines ran cleaner and longer. New variants simplified maintenance. Standard parts spread across models. Training engines matched combat ones. The learning curve flattened. Losses dropped further. Even as missions grew harder, reliability stayed high. The role expanded. Transports flew farther. Bombers carried heavier loads. Fighters climbed faster. The engine kept pace. When the war ended, the numbers spoke clearly. American aircraft flew millions of hours. Mechanical failure rates stayed low. Thousands of lives returned because engines held. The early doubts faded into history. A captured German pilot reportedly said they thought quantity meant weakness, and they were wrong. The legacy remains. Industrial trust, built by unseen hands, can decide the fate of wars.